So 9.3b, this is still over section 9.3, but it's all word problems that we're going to convert into rational equations. So here's our first example. Apparently that's Kelsey. Kelsey is kayaking on a river. She travels 5 miles upstream and 5 miles downstream in a total of 6 hours. In still water, what's still water? Water that's not moving, right? Kelsey can travel at an average speed of 3 miles per hour. What is the average speed of the river's current? So obviously the river's current is either helping her move faster or it's making her move slower if it's working against her, right? So we need to find out what the average speed is. So we're going to start off by identifying important information. What is our answer going to be? It's going to be the average speed of the what? Current. That's what we're looking for. The river's current. Kelsey spends how long kayaking? 6 hours. She travels how far upstream? 5 miles upstream. And how far downstream? 5 miles. Hopefully that makes sense, because if she's traveling 5 miles away, she should travel 5 miles back to get where she started, right? Her average speed in still water is 3 miles per hour. So we're going to take that information and we're going to make a plan. Let's let C represent the speed of the current. What's nice about these problems is you don't necessarily have to use X. You can use X if you want to. Sometimes we do just because it's a habit. But they're saying let's use C, so that way when we get our answer, we remember that C means current, right? When Kelsey is going upstream, her speed is equal to her speed in still water minus or plus C. When you're going upstream, is the current pushing against you, or is it going with you and making you go faster? It's pushing against you. So her speed in still water would be subtracting the speed of the current when she's going upstream. When she's going downstream, her speed is equal to her speed in still water plus C. If you've ever been on an airplane and gone somewhere in the United States-ish, they'll talk about the jet stream. Have you ever heard of that term? The jet stream. It's kind of the same idea as a current, that when you're flying, I can't remember what direction it goes, but when you're flying one direction, east to west or west to east, like if you're flying from here to Washington, D.C., you're going to have actually a shorter flight because the jet stream is helping the plane go faster. Whereas when you're flying the other direction, the jet stream is blowing against you, and so the plane is actually having to work harder to keep up that speed. Yes, sir? The jet stream is kind of like a river of air. Tailwind, I think, is a specific wind that might be in a specific place, but the jet stream is like a river that goes through. I'm not an expert on that by any means, but I do know about the jet stream. I do know how that works. Okay, the variable C is restricted to positive real numbers. So if we get a negative answer, we have to exclude it. Why is that? Because what's the answer we're looking for? We're looking for the speed of the current. Can you have a negative speed? No. Like in your car, you can't have a negative speed. It's always a positive speed, right? Okay, so we're going to complete the table here. Upstream, she goes 5 miles. And downstream, she goes 5 miles. What is her average speed going upstream? Upstream, her speed in still water, which is 3, minus C. Right? That's what I just wrote in the paragraph up ahead, or up above. Downstream would be her speed in still water plus C. Her time. Let me introduce you to a formula. You ever seen that formula before? Distance equals rate times time. Well, another word for rate is speed. So if I'm trying to find the time, let's get the time by itself over here. Wouldn't I divide by r? So I could say that time is equal to distance divided by rate. Does that make sense? So if I took the distance, 5, and I divided it by the rate, or the speed, 3 minus c, that gives me an expression for the time. Distance down here over the rate gives me an expression for the time. So let's interpret this a little bit. So as far as going upstream, we know she went 5 miles upstream. We know this was the average speed, or a representation of the average speed, and this represents the time it took her to go upstream. Downstream, she went 5 miles. That was the speed, and this represents the time she went downstream. So what would I say about the time she went upstream and the time she went downstream? Well, that's where this comes in right here. Her total time, what was her total time? 6 hours. Would equal the time she spent going upstream, which we're saying is 5 over 3 minus c, plus the time going downstream, which we're saying is 5 over 3 plus c. Does that make sense? Time going one way plus the time going the other way equals the total time. Now that I have it in an equation, this should look like something you did last night for homework. What do I need to do? Find the LCD. Now, they have it step by step over here. I'm going to kind of ignore that and just do it the way I did yesterday. What's my denominator over here? 1. 3 minus c, can that be factored? No, so I'm going to put it in parentheses. 3 plus c, can that be factored? No, so I'm going to put that in parentheses. So what would you say is my LCD? It would be 3 minus c and 3 plus c, because both of those are represented denominators, or represented parentheses. So now I'm going to write it with the awkward spaces like I did yesterday. So I'm going to write the 6 over 1, leave a space, equals 5 over 3 minus c, leave a space, plus 5 over 3 plus c. Now, before I go much further, should I talk about excluded values from my LCD? What can c not equal? 3 and negative 3. Because 3 minus positive 3 makes that 0. 3 plus negative 3 makes that 0. Okay? Now, what am I going to put in my awkward spots there? LCD, 3 minus c, 3 plus c, over 1. 3 minus c, 3 plus c, over 1. And 3 minus c, 3 plus c, over 1. So let's do our canceling. This becomes one giant fraction, and nothing cancels out in this first one, does it? So I just have 6, parentheses 3 minus c, parentheses 3 plus c. You okay with that? Equals. What cancels out when I make this one giant fraction? 3 minus c, so I have 5, parentheses 3 plus c, plus, making this into one giant fraction, what do I have? What cancels? 3 plus c, so I have 5, parentheses 3 minus c. Now I'm going to have to make it look a little bit uglier. I'm going to have to multiply everything out so I can start getting common like terms together. So I'm going to leave the 6 out in front for a minute while I multiply this. 3 times 3 is 9, plus 3c, minus 3c, minus c squared, equals 15 plus 5c, plus 15 minus 5c. So far, so good? I noticed some things that will cancel. Do you? Yes? I see 5c and negative 5c, which means on this side I have 30. I also see this right here, that those two are going to cancel. You see that? Positive 3c and negative 3c. So I only need to distribute this 6 to the 9, which is 54, and then to the negative c squared, minus c squared. So I have 54 minus c squared equals 30. I'm sorry, minus 6c squared. Thank you for catching that. Now, am I going to need to factor this? With a c squared, I could need to factor it. However, do you notice that there's no b value? There's no plain old c term anymore. So I can actually just get the c squared by itself and go from there. So I'm going to subtract the 54. And what does that leave me with? Negative 6c squared equals negative 24. Now what should I do? Divide by negative 6. And c squared equals positive 4. When I square root this, I have to remember a plus or minus. I get c equaling positive 2 and negative 2. Now, are either of those my excluded values? No. So that's good. What is my answer representing again? The current of the river. Do both of my answers make sense for that? Why not? I can't have a negative current, so I have to drop off the negative 2. I can't say that the current is negative 2. So I would say that the current is 2 miles per hour. So even though this wasn't an excluded value, it was a restriction that we put on here because we knew we had to only talk about positive real numbers. That's also known as a restriction on the domain if we were to graph this. We're not going to graph this, thank goodness, but if we were, that would be a restriction on your domain. Okay? All right. Turn to the backside. The solution, c equals negative 2, is unreasonable because the speed of the current cannot be negative. But the solution c equals 2 is reasonable because the speed of the current can be positive. This is the way the book states it. I feel like it's kind of overkill sometimes. If the speed of the current is 2 miles per hour, it would take Kelsey how many hours to go upstream? Five over 3 minus 2, right? That represents the time. What's 3 minus 2? 1. 5 over 1 is... So it would take her 5 hours to go upstream. That's dedication. I would have given up. My arms would die. And how long to go downstream? How long time-wise? 1 hour. First off, I know that because it says she went 6 hours total. Second off, I know that because if c is 2, 3 plus 2 is 5, and 5 over 5 is 1 when I solve it there. Okay? So she was there for a total of 6 hours. Why does the domain of the variable have to be restricted in real-world problems that can be modeled with a rational equation? Well, we kind of discussed that. The domain was restricted because we can't have a negative current. We can't have a negative time. We can't have a negative speed. We can't have a negative distance. So depending on what kind of circumstance you're talking about, you may have to say, we have to throw out all negative numbers. Okay? I'm not going to write that in there. We just talked about it, so we're good. All right, the next type of problems that you're going to see are called work problems. And whenever you have a work problem, you want to set up a little table like this. You're going to have 2 people doing 2 different jobs. You want to talk about rate times time equals the amount of work done. So let's look at it. The best way I can explain that is to go straight through one. One computer can schedule classes for all the students in the school in 5 hours. So when they put in everybody's requests and whatnot, one computer can do the job in 5 hours. A newer computer can do the job in 4 hours. If the computers work together, how long will it take? So, computer A can complete one full job in how long? 5 hours? When I say one full job, I mean something that's 100% complete. What would I say about computer B? It can complete one job in how long? 4 hours. I have 1/5 right here and 1/4 down here. Since we're trying to find how long it will take, we don't know the time. So I'm just going to put T and T. Because we don't know the time. And the equation is kind of set up for you. Do you see how it says rate times time equals how much work was done? So 1/5 times T represents how much work was done by computer A. What would be the representation for this guy, for computer B? 1/4 times the time. So how do I take this and I set an equation up then? Well, I need to take the amount of work that computer A does plus the amount of work that computer B does, and I want to see when does that equal one full job being complete. So these work ones, it's handy because it's always going to equal 1 when you're setting it up. So? Now what did we decide yesterday with the T, or with the letter outside? Where does it go? With the numerator. So 1/5 T would be the same as T over 5. 1/4 T would be T over 4 equals 1. What's my LCD? 20. So I need to multiply each of these by 20 over 1. So if I do some cross-canceling, the 5 becomes a 1, the 20 becomes a 4, and I have 4T. Yes? Plus, over here, that becomes a 1, and that becomes a 5. 5T equals 1 times 20 is 20. What is 4T plus 5T? 9T equals 20. Divide by 9. Can 20 over 9 be reduced? No. So, T equals 20/9 hours. Now that's kind of funky because that really doesn't help me say how long it took, right? When we're talking about hours, it might actually make more sense to go to a mixed number in this case. We don't often go to mixed numbers, but can you tell me approximately how much time that is? A little bit more than 2 hours, right? Because wouldn't 2 hours be 18 over 9? So it's a little bit more than 2 hours. Is it 2.5 hours? it would be a little bit less than 2.5 hours, I think. Okay. Yeah. So it would take them a little bit less than 2.5 hours to do the job together, those two computers. Okay. All right, let's try one more of these. Jan can tile the floor in 14 hours. Together, Jan and Bill can tile the floor in 9 hours. How long will it take Bill to do the job alone? So, Jan, we're going to call A, Jan, and B, Bill. So Jan can complete one job in how long? 14 hours. Bill can complete one job in how many hours? We don't know, so we'll call it X hours. That's what we're trying to find out. Working together, this is their time, would be the time working together. Up here, we didn't know the time working together, which is why that was T, but this time we do know the time working together. What is it? 9 hours. Took them 9 hours to work together. Equals the work done. Well, 1/14 times 9 for Jan. If I'm unsure, I can go to my calculator. 1/14 times 9 is 9/14. So she did 9/14 of the job. 1 over x times 9 would be 9 over x. So what would my equation be that I set up? Her work plus his work equals 1 full job completed. So what's my LCD? 14x. So I'm going to take each of those. See, I think I need to give myself a little more space. 9 over 14 plus 9 over x equals 1. I need to multiply each of those by 14x over 1. So, in my first one, what cancels? 14, so I'm left with 9x. In the second one, what cancels? X's. So I need to figure out 9 times 14. 126 equals 1 times 14x. 14x. How should I solve this? Move the 9x. So 126 equals 14x minus 9x would be 5x. Let's divide by 5. And x equals 126 does not divide by 5 nicely, and I don't think it can reduce. But you know what? I should have done it on the last one. Let's go ahead and go to decimal, because that's going to make more sense. Because 126 over 5 hours means nothing to me. When I'm sitting there going, okay, so how many hours do I schedule you for the day? It doesn't help me. But if I do 126 divided by 5, and I see, oh, that's going to take 25.2 hours, now I know, okay, if you work 8 hours a day, that's 3 days, and then a little bit of time on the 4th day. That's more meaningful to me, especially if I was an employer or something like that. So we're going to say, Bill, sorry, bud, you're a little short, or a little slow, but it takes you 25.2 hours to tile the floor by yourself. He's a little slow. Okay. Probably should have done that up here also, but at least this one was a little bit more reasonable to guess on, because 9 times 2 is 18, and that was pretty close. Okay. I will specify on a test or a quiz whether I want you to leave it as a fraction or whether I want you to just go ahead and give it to me in a decimal. Okay. All right.